This is lesson 12-7, Bivariate Statistics. So far in this chapter, we've been studying univariate statistics. Univariate statistics involve just a single set of numbers, whereas bivariate statistics will involve two sets of numbers. Bivariate statistics also involve the relationship between those sets of numbers, the data sets. A graph that will show the pairs of values in the data for both sets as plots on or points on a graph. We plot the points, and it's called a scatter plot. This is an example of what a scatter plot would look like. The two variables, the two data sets that we have here are the year and the local index, which typically refers to the temperature of some sorts. Could be a particular season average, could be a particular day of the year. We would have to know more information from the actual statistical data and what it's all about before making a judgment as to what the local index means there. Let's talk about correlation and causation. Correlation is the description of the relationship between the two sets of data when you're working with bivariate statistics. There are three kinds of correlation that are possible. We have positive correlation, which means as one set of data increases, so does the other. We have negative correlation, so as one set of data increases in value, the other one goes down in value. And then we have none or no correlation, which means there is no pattern discernible with your scatter plot. Causation is the act of one of the variables causing another to happen. That typically is something that's inferred. It is done through your own thought process. For example, an increase in the number of miles that you are driving, unless of course you have a completely electric car, would cause you to use more gasoline. We could certainly put that data on a scatter plot, and because we know the two data sets, we can infer that causation is possible here. When we do a scatter plot, the main idea that we have with a scatter plot is to find what's called the line of best fit, or a trend line. The line of best fit will aim towards the middle of the data on a scatter plot, and it will show us how the data is trending, if it's trending at all, and how quickly the trend is changing. And of course, when we're talking about change with a line, we're talking about the slope. To the right is an example of what the line of best fit would look like. The line is here in blue, and that is what we call, again, the line of best fit, or a trend line. It's showing how the data is trending with the year and the local index. The distance between any point in a scatter plot and the line of best fit is called its residual. So for example, I'll do an example here. I have this point right here. I'm going to circle. And if I measure the distance between the point and the line, the amount of change, both with an x residual and a y residual, we will have this distance here and this part right here that I'm drawing an arrow to. That's called the residual. And we can plot on a separate graph, and we will do this eventually, we can plot the residuals on a graph and see how good the line of best fit is as it relates to the bivariate data. You can always find the equation of a line of best fit, and it's the easiest way to find the equation of the line of best fit by using the lin-reg function in your TI-84 graphing calculator. That is under the statistics menu. When you hit stat in your TI-84, you arrow over to the calc menu, and that is where you will find the lin-reg function, and it will give you, provided that you put in the two lists of data, it will give you the line of best fit for that data. The next slide will be an example of when to do it, And then on the slide after that, I will show you exactly how to do it on the TI-84 graphing calculator. So here's an example scatter plot problem. The chart at the right compares students' study time with students' correct answers on a test. Based on the chart, complete the following. So there's 4 things you need to complete here. The first thing you need to do is draw a scatter plot with the study times on the horizontal axis, the x-axis, and the correct answers on the vertical axis, the y-axis. I want to know what kind of correlation it is. I want you to know, is there causation? And then use the graphing calculator to draw in and find your equation for the line of best fit. Pause the video at this point to give yourself a chance to try it on your own. Okay, so I am on my TI-84 Plus. You can also do this with a TI-83. The first thing I want to do is enter in my list. So I'm going to hit the Stat button. And I'm going to hit Edit. In the first column, I'm going to put my X values, which are 10, 20, 25, 35, and 40. I'm going to right arrow over to L2, and I'm going to put in the Y values that match up, the correct answer that match up with the study times. 15 matched up with 10, 28 matched up with 20, 37 matched up with 25, 51 matched up with 35, and 60 matched up with 40. So I have my 2 lists in, and now I want to go to put them in a scatter plot. So the first thing I'm going to do is go to my y equals, and I'm going to arrow up to plot 1, and I'm going to hit enter. That turns on my stat plot, which is exactly what I want. Okay? Now, when I go to the graph, you'll notice that it's the regular normal 4-quadrant graph, and I can't see any of the points. To see the points, we want to hit the zoom button, and if you go all the way down to number 9, as I will be doing right now, you have zoom stat. Since we're working with statistics, we do want a zoom stat here. I'll hit enter, and there is my scatter plot. So to see what the window looks like, or how the x and y axis are going up, if you're sketching this, as you should be, you want to hit window, and it's going to give you what the x minimum 7, x maximum 43. It's going up by 1. You don't have to have that big of a scale. The y minimum, you can go from 7 to 67. And again, that's also going up by 1s, but again, you can go up by 5s if you so choose. And so what we have here, if I go back to the graph, is that it's what your scatter plot looks like. Obviously, from what you can see here, and we'll put the line of best fit in momentarily, but you can see that we have a positive correlation. We can also infer from this that because it's study time and correct answers, that we can also say there is causation with this particular bivariate statistical data. So we have positive correlation and causation to start. Now, to get our line of best fit, the next thing that we want to do is to go to Stat and go to Calc, as I said before, and we want to run a lin reg. That is number 4, and you can see it's ax plus b. They're going to give you the values for a and b. So I'm going to hit 4, and then I'm going to hit enter. And as you can see here, they're very long decimals because the calculator is extremely precise. And so what I have here is y equals 1.50. I'm actually going to round it to hundredths. 1.50x minus 0.75. If I want to see what the line of best fit looks like and how close it is, if I need to measure residuals, what I will do is I'll go to y equals. I'll go down. I am in y1. It's exactly what I want. That's where I want my cursor. Then you can hit vars button here, statistics number 5. you can arrow over to the reg EQ or EQ and find reg EQ, hit enter, and it will automatically put the line of best fit in the calculator for you, and then you can hit graph, and as you can see, it will graph the line of best fit for you. You can see the third point right in the middle is exactly on the line. There would be no residual with that at all if I was asking you to measure residuals. The coefficient of variation is another measure of dispersion, and this one we use with bivariate statistics when we have two sets of data. The coefficient of variation, which is abbreviated as CV, it's the ratio of the standard deviation to the mean expressed as a percentage. The CV is calculated with bivariate statistics to show which set of data varies more or which set of data varies less. The formula for the coefficient of variation is the standard deviation divided by the mean times 100. Again, it is expressed as a percentage. We can find the mean and standard deviations of both sets of data simultaneously in the graphing calculator using the two-variable statistics function in the calculate menu under the stat button, as I will show you on the example answer slide. Here's your next example. It's the same two sets of data. This time I want you to find the coefficient of variation for each set of data, and I want you to tell me which set of data varies less. Pause the video at this point to give yourself a chance to try it on your own. So as you can see, I have my two lists still in the calculator, and now I need to go and find the mean and standard deviations of both lists. So what I go to here is I go to the stat button, and I'm going to go over to calc. This time, since I have two lists, I'm going to go to two variable statistics. I'm going to hit enter twice, and it comes up with my mean for X as well as the sample standard deviation that I require. If I arrow down, I can obtain the same information for Y. I'm going to need those two numbers, the mean and the standard deviation, to calculate the coefficient of variation. Now that we've found our standard deviations and means, we can go ahead and calculate the coefficient of variation. For X, it's the standard deviation of X, which is 11.94, divided by the mean, which is 26, times 100, which approximately gives us 46%. Calculating the coefficient of variation for Y, we have 17.91, divided by 38.2, times 100, which gives us approximately 47%. Therefore, the study times will vary less than the correct answers by just 1%. If you're having any issues with this particular lesson, please make sure you consult your teacher in class.